This video is a product walkthrough of the WebGrapher platform, focusing on the user interface and real-time behavior. Let's start by exploring the WebGrapher user interface. The first thing to notice will be adding JWT authentication to our API, which will require users to log in. After logging in, we're presented with the Connect to Graph modal. This shows a list of graphs we've previously created. At the top of the modal is a button that allows us to create a new graph, and at the bottom are paging controls if we have many graphs. When rolling over a graph, we are presented with some options. We can either delete a graph. To delete, we must click the Confirm button, or we can connect to a graph. Let's go ahead and connect to the Movies graph. Once connected, data from our graphing database is fetched via the API and presented to the user as a graph on the screen. A graph is made up of nodes and edges. Each node represents a web page, and each edge, which are the lines connecting nodes, represents a link to another web page. We can zoom in, pan around, and zoom back out. As we zoom out, you'll notice the level of detail is reduced. When nodes become small, their images and labels are hidden. We reduce the level of detail to increase the rendering performance on the client. This allows us to maintain good performance when we have graphs with thousands of nodes. The user interface we're going to create is a static single-page application built using Vue.js. For graph visualization, we'll be using Sigma.js. At the top of the page is a navigation bar. As we zoom into our graph and pan around, we can click the name of the graph in the nav bar to return us to the default zoom and center position at any time. Clicking on a node will select and highlight that node. When a node is selected, the node sidebar appears on the left. The sidebar contains data related to the node, such as its title, an image, summary text, which can be expanded to show more. We also have outgoing and incoming links to other nodes. At the bottom are the top 10 keywords or tags related to this node. If we click on another node, the information in the sidebar changes to reflect that of the selected node. When a node is selected, the node and its immediate neighbors are highlighted. All other nodes are reduced in size and the image is hidden. This allows us to focus on the selected node and its immediate neighbors. Here, the actress Scarlett Johansson is only connected to the movie The Avengers. Therefore, all other nodes are reduced in size and their image is hidden. When I select the Avengers node, as it's connected to all the other nodes, their images are shown as these nodes are its immediate neighbors. In the sidebar, we can see a node's neighbors are represented as either outgoing or incoming links. Clicking a link will select that node, and the information in the sidebar is replaced with that of the selected node. Notice how each link has a focus icon on the left. Clicking the focus icon will focus a node to the center of the screen without replacing the information in the sidebar. This is helpful when we want to explore related nodes while retaining the information in the sidebar. You'll notice each node also has a source link, which is the address of the web page that the node represents. In this case, clicking the source link takes us to the IMDb page for Avengers: Age of Ultron. This is the web page from which the information for this particular node was extracted. In the sidebar, you'll notice that nodes also have a crawl button. Clicking the button will display the crawl form. The crawl form allows us to crawl a web page, and notice how the node's source address has been pre-populated into the form. This makes it easy for us to crawl a node for additional information by simply pressing the crawl button associated with that node. Below the URL are two sliders which I'll discuss later. Clicking the preview button will start a series of events that are processed by the backend microservices. Our microservices will start crawling the website, scraping the web page, extracting and normalizing the data before displaying a preview back to the user. Here we can see the data that was extracted, such as the title, an image, the summary text, and a bunch of keywords that have been condensed from the body of the page. From these, we select the top 10 keywords represented as a list of tags. Once we are happy with the preview, we can click the back button and then go ahead and click crawl. Crawling the web page will start a series of events that extract the data, map the relationships to the graphing database, and then trigger further crawl events when links to other pages are discovered. Crawling a page creates a recursive loop through the system, which will continue until either we reach the maximum depth to crawl or there are no more links to follow. In this instance, when we crawled the web page of Chris Hemsworth, it discovered one outgoing link to the movie name Thor, proceeded to crawl that page, but then stopped crawling any further pages as we set the maximum crawl depth to 1. Notice how, when crawling pages, the activity sidebar will appear on the right of the window. This shows a live log stream from the microservices as they process events. Let's go ahead and crawl the Thor webpage. From the crawl form, we can use the sliders to set the maximum number of links to crawl and the maximum depth to follow. For example, if a web page contains 10 links to other pages and the depth is set to 1, the crawler will follow each of those 10 links before stopping. At a depth of 2, the crawler follows 10 pages from depth 1, plus up to 100 pages from depth 2, potentially crawling 110 pages from a single request. Increasing the depth further causes the number of pages to grow rapidly. At depth 6, a single web page could lead to over 1 million crawl requests, assuming just 10 links per page. Crawling is a recursive process, and setting a depth prevents it from continuing indefinitely. Let's reduce the depth back to 1 and keep max links at 10. Now, here is the information extracted from the Thor movie webpage. And here are the 10 links we extracted from the page. If we now go ahead and click the crawl button, this will trigger a crawl event to the microservices. As the microservices start processing, the activity sidebar displays a live log stream of events. As each of the pages are crawled, the discovered nodes and edges are streamed live into our graph. Let's find another node to crawl. Let's crawl the actress Scarlett Johansson. Set max links to 10 and click crawl. You'll notice as the nodes and edges are inserted, the layout animates and adjusts to accommodate the new data. We'll implement this animation using the Force Atlas 2 physics engine to define how nodes and edges behave. The Force Atlas algorithm works by pushing all nodes apart like charged particles, while edges pull connected nodes together like elastic bands. This balancing of forces helps form a clear clustered layout that is ever-changing and fun to watch. Let's add some more data by crawling some more nodes. As the data streams into the graph, let's click on the actress Kate Blanchett to see the information extracted. Under the outgoing links, there is a relationship to the movie Lord of the Rings. Let's go ahead and crawl this movie. Once again, the microservices start working to discover and map the information and then stream it into our graph. As you can see, The layout is being automatically adjusted to represent the relationship of the data found. Let's crawl another actor. Let's crawl Elijah Wood. While it's doing that, let's find somebody else to crawl. Let's crawl the actor Chris Hemsworth for additional information. As you can now see, we are starting to build up a complex graph of movies and actors. From our web graph, we can now start exploring relationships it's found in the data. The actor Elijah Wood is connected to the movie Lord of the Rings. That's connected to Ian McKellen, who played Gandalf in Lord of the Rings, and he's connected to Avengers, where he played Magneto. The Avengers movie is connected to Chris Hemsworth, and he's connected to the character and the movie Thor.